Okay, everybody, it's me, like I said, haunting you from the digital world, wherever you think you could hide from me. Guess what? You never can hide from your BC calculus teacher. Okay, so here's what we're going to talk about. I left talking about the idea of net signed area being the area bounded between the function and the x-axis. So here's what we're going to do right here. We're going to look at question number 1 together, okay? And for some reason, my version is blurry, but yours is pristine, so I'm okay with that. We are looking at the net signed area bounded between the function f of x and the x-axis from -2 to +3. Follow my pen here. We are going from -2, okay, to +3. I'm going from the left to the right, okay? And what I'm looking at here is the area bounded between the function f of x and the x-axis right here from -2 to +3. That area is 7. Now, I'm going to do something with you over here. I'm going to put down a +7. That's what that equals. And you're going to ask me, well, Ms. Yam, why is it +7 and not -7? Okay? Come down to question number 2. Question number 2, I'm going to erase these markings. It looks very similar to question number 1. It's asking you to find the net signed area bounded between f of x and the x-axis from 3 to -2. From 3 to -2, okay? Wouldn't this answer here be the same as this answer here? And here is where I'm going to play loose and free with areas and lengths, okay? What I want you to do is just come over here and look at this little shape for me right here, okay? Look at this area bounded by 7. What I want you to think about is the fact that when I go from 2 to 3, I'm moving in this direction. This dimension here is then a positive dimension. I'm going from left to right. The x is increasing. Think of increasing x as a positive dimension, okay? Notice here that my function is above the x-axis. The function's above the x-axis. I have a positive length maybe, and I have a positive height. You understand? So I know this is not a rectangle. I'm playing loose and free, but a positive dimension times a positive dimension equals a positive area, right? A positive net signed area. Let's come back to this idea for question number 2. We're looking at the same region here, but notice something. I'm going from 3 to -2. I want you to think of this dimension then, this length, say, as a negative, right? It's a negative, say, length, but look, f of x is above the x-axis, so a negative length times a positive height, the net signed area is going to be -7, all right? Like I said, this is our first day with the definite integral, and I'm just planting some ideas in your head. Okay, there's a full formal definition of this that's very rigorous and robust with mathematical notation. But right now, I just want you to get comfortable with the idea of how an area, a net signed area, could be negative. Are you all understanding me? All right, let's go to question number 3. Okay, we're going now from -6 to -2. Okay. From -6 to -2. The net signed area bounded between f of x and the x-axis from -6 to -2. I'm going to go here. I'm just making note. I'm going in that direction. Here is the function f of x. Here is that region. That's the region bounded between the function and the x-axis. Now let's think about this. If I'm heading from -6 to -2, this dimension is a -1, right? But look at the function here. See how the function's below the x-axis? So this dimension is a -1 as well. I'm sorry, I just misspoke. -7 to this dimension is a positive one. I'm sorry. This dimension is positive, this dimension is negative. What do you think the, not area, the net signed area is going to be, it is going to be -5, right? So you'll notice we make a very big deal, or I made a very big deal of emphasizing the fact that the definite integral is not just area. That is wrong. It's wrong to say the definite integral is just area. It's correct to say that the definite integral is net signed because the sign matters. It's net signed area. All right? All right, let's go to question number 4. Okay, let's erase. AB, don't you dare race ahead yet. Don't you dare. I see you. I can see if you're racing ahead. Don't you do it. From x equals -6 to x equals 7. Here we go. We're going all the way from x equals -6 all the way to x equals 7. We want to find the net signed area bounded by f of x over this entire interval of x, and the entire interval of x, and importantly, in this direction, in a direction of a positive horizontal dimension. Do you see what I'm saying? Now, what I'm going to do here is kind of break this up, because I see that if I take a look at this, kind of break this up for a second, right? I'm going to make a note of myself that this is a negative dimension, this is a positive dimension, this is a negative dimension. So it's clear to me I'm moving from -6 to 7, okay? This net signed area from -6 to -2, I know is already -5. Plus this dimension in the middle here, right? Positive dimension, the area is a positive times a positive, so +7. Then we're in this final piece here. Look what's happening. Positive dimensions, so we're heading to the right. Negative dimension, the area here is going to be -3. So my net signed area from -6 to 7 of f of x dx is going to equal -1, because I add them all up. Do we understand? Everyone okay? All right? Okay, why don't you go ahead, let's take a look at number 5, 6, 7. Go ahead and do them and then check me for answers. Okay, here are the answers right here. I'll go over maybe 7 and 5, okay? Number 5, the definite integral from 3 to -2, right here, and I'm just making a note heading in this direction. Negative dimension times a positive dimension, right? -7, yeah? 7 to 3, I'm going to go from 7 to 3. So from 7 to 3, right? Heading this way. 7 to 3, negative dimension, positive area, +3, positive net signed area. 3 to -6, okay, 3 to -6. Well, from 3 to -2, I know this is going to be -7, plus, if I keep going, 3 to -6, right? 3 to -6, right here, from 3 to -6, negative dimension, that's a +5. Okay, so that's why we get a -2 in the end. All right, everyone okay? Very good. Don't forget, I see you. Okay, page 2, please, come with me. Actually, you know what? I'm going to leave that alone. Now go to your homework in the book on the teacher page. And boy, oh boy, am I going to check my section references. Adios, species.